So in order for an object or an expression to be in simplest form, it cannot have any like terms, and it can't have any parentheses. By parentheses, we're not talking about the parentheses that just separate a negative sign from an addition or subtraction, something along those lines. I'm talking about parentheses that involve operations within them. And we'll explore that a little bit. So that's the check. When you get done with your answer, when you get an answer that you feel like is simplest, check to make sure that those two things are true. Are there any like terms? And if you say no, then check, are there any parentheses that need simplified? And if the answer is no, then you're in simplest form. So today we're going to look at how do we take and apply that distributive property concept, the algebra tile concept that we did with like terms, and use them to simplify expressions. If you look at letters A and B, though, these do not include anything that would require the distributive property per se. You could do this without the distributive property. You could do this using those tiles that we've been using the last couple of days, although I'm not going to ask you to do that. If you take a look at letter A and kind of do what we would do in the last couple of days with identifying coefficients, constants, like terms, and all of that, tell me, where do you see any like terms in letter A? Matt? 8n and 4n. Now, do you guys remember what we talked about yesterday with like terms? I said that you cannot combine like terms using which, or I'm sorry, let me rephrase that. You cannot combine unlike terms using which operations? So if I have two terms that are not like, I can't do this with them. Add or subtract. I cannot. I can multiply or divide them, but I cannot add or subtract them. Well, I have an unlike term here with the 4. So that means that I cannot combine it with these other two terms. However, since these two here that I've highlighted are like, then I can combine them. And this may seem tedious, but I'm going to rewrite this. And I'm going to rewrite it in a way that puts my like terms next to each other. This is not a requirement. This is a step that might help you, especially early on when we get used to, before we feel super comfortable with these. Since we had everything addition, that allowed me to move it around. So you told me that 8n and 4n were like terms. So imagine having 8 of those green bars and 4 of those green bars that we use for algebra tiles. What would you get when you simplify those two? Amelie? 12n. You just add the coefficients, 12 and 4, or sorry, 8 and 4, 12n plus 4. Are we done? A lot of people saying yes. Well, the definition of simplest form is that you have no more like terms, and we have no more parentheses. So that, by definition, is in simplest form. And until or unless I tell you what n equals, you can't go any further. I want you to try letter B. Do it in pencil, because it's quite possible you'll make a mistake. Just try it. with that, so you can't combine them together. When I walked around, I did see several right answers. However, I did see several incorrect answers on there. Let me suggest something to you on this that I think will help. If you got it right, chances are you did this. I shouldn't say chances are. You may have done this. I don't know if you did. But if you didn't get it right, then I would highly suggest you consider doing this moving forward. I think letter A was rather simple for the fact that we only had addition. And what does addition allow us to do that can help us simplify an expression? By having everything addition, Justin, exactly, moving around, any numbers, just figure it out, put it in the order that makes sense to you. I can't do that right now with B. Or I can, but it's not as easy. So my proposition to you is, let's turn this into an addition sentence. We have the skills to do that. We know what to do when I see minus 5x. What could I do there? Andrew? I could write that as plus a negative 5x. And what could I do with a minus 7? Sullivan? Add the opposite, plus negative 7. Now, tell me, where are my like terms? Give me some like terms. Sophie? All right, so I've identified the like terms. Now, you don't have to do this. You might just think this in your head, but I'm going to rearrange them so that my like terms are next to one another. And I can do that now because of the commutative property. So plus 4 plus negative 7. All right, you combine your like terms. Here, here. What do you end up getting? Victor? 1x or just x. Go ahead. Yeah, you could have minus 3, or the way I wrote it, it would just be plus a negative 3. But yeah, x minus 3 is the same. It's an equivalent expression to that. Some of you, I noticed, had 11x when I was walking around. Okay, now, that's not correct, of course, but I know what you did. You looked at this like 6x plus, oh, here, there's a like term. So 6x plus 5x. There's my 11x. You're not adding 5x. You're adding the term right after 6x, which in this case is the 4. You're subtracting 5x. But sometimes we forget that. But if you change everything to add the opposite, you don't have to worry about forgetting it. Everything's addition anyway. So I would just suggest that as we go forward here. All right, now C and D are slightly a different animal here. Now we have some parentheses that we have to deal with. Why don't you give C a shot first? Rather than me telling you how to do it, I want to see what you can come up with. let me just help you to relax here. If you're not getting the right answer, that's okay. And if you're looking at this thinking, man, I don't know how to do this, that's okay too. This is our first run at it. So it's not, the expectation is that you aren't going to get this right away. If you did, that's awesome. But if you didn't, don't get discouraged or anything like that. You're going to learn this. Remember what my suggestion on the previous one about adding the opposite. I would highly suggest that on this one. So the very first thing, and to this day, I still do this. And I've solved a lot of these in my time, but I still prefer looking at this as add the opposite. I like addition way better. Now, can I add y and negative 2 together? I can't. No, they're not like terms, right? I can multiply, but I can't add them together. So if you think about the order of operations, which is what you would follow when you're simplifying, the order of operations says that we would do negative 3 times y first. Now, great. I can't do anything there because I don't know what y is. And then I would take that and add it to x. I can't do that either because they're not like terms. What can we do here? What are we allowed or permitted to do to start with? Dominic? The negative 2 here now, like I changed it, I can multiply that by this right here? I can. What else can I do with it though, Dominic? Can somebody tell me? What else can I do? Go ahead, Sophie. Yeah, I can also multiply here. This is the distributive property. Remember, they don't have to be like terms in order for you to multiply them. So y doesn't change. I still have addition. Now, somebody tell me what this is going to equal when I distribute the negative 2, something that we have been working on here recently. Andrew? Close. That's a negative 2 now times a negative 3 plus 6y. Now just take a second and try to digest that and see exactly what happened there. And if you want to ask a question, ask it. If you're not sure what happened there, try to figure it out. Ask it. Now what we've done is we've freed it up a little bit. Now we have that freedom to move terms around. So where are our like terms in this expression? Matt? Exactly, y and 6y. Since this is everything's addition, just for peace of mind, I'm going to put them next to each other. Although you don't have to. You can just look ahead and add them. So now we combine our like terms. What's that going to equal then? Go ahead, Matt, you can finish. 7y, yeah. Plus what, Matt? Yeah, I was looking, when I went around, I was correcting some, I forgot that was a 3y there. So I think I told you 4y would work, but that wouldn't work. It was 7y. So I'm sorry for those of you that said, yeah, that's good. It should be 7y plus a negative 2x. I'm being silent. I'm letting it settle in. See if it's making sense to you. If you feel like it made sense to you, go ahead and try D. If you're not sure, and you want to ask me a question, call me over. I'll help you out with it. Go ahead and give D a shot. better than the previous one already. I've been seeing that when I went around. Good. Okay, so out of curiosity, because I can't remember off the top of my head, how many of you made one of your first steps into add the opposite? How many of you did it? Great. That's probably why our success was higher on the second one than on the first one. So add the opposite, add the opposite. All right, tell me what you did next then, after you did that step. Olivia? Yep, you distributed that -3 through. So you did this. What did you end up with, Olivia? And I'm just going to put the -3 in parentheses just to separate it. Then where do we go? Misty? Like terms are right here and here. And you get, this becomes 12y. Go ahead, Misty, what's left? Added -3x. So for those of you that had 12y minus 3x, it's the same thing. That's an equivalent expression. All right. Feel a little bit better after seeing another one now? These will get, they're going to get tougher, but at the same time, you're going to get better at them also. So you'll be able to meet the challenge that we put out there. Let's take a look at example 3 and practice writing a couple of these. Maybe we might be able to get the first one done, but that's fine. All right, suppose you and a friend worked in school store last week. You worked 4 hours more than your friend. Tell me something about you and your friend. First impression. David, you worked more. What's that mean? Victor, your friend's a slacker, all right? Sullivan, you get more money. What about you? What's that say about you? Ella, you're an overachiever. You work hard, right? Great. Unfortunately, none of that has to do with the problem, but I like the way you're thinking. Let me show you one thing. The expression here, it says you worked 4 hours more than your friend. Let's write this before you leave. Let's say H is your friend, like your friend's hours. So if your friend worked H, what did you work? You overachiever. Andrew? 4 more than H? So, well, you worked 4 more than H, because this is your friend. And then you did H plus 4. So in total, both of you together worked how many hours? Let's simplify. Adrian. 2H plus 4. Good. All right. Bye. See you tomorrow.